In this video, we're going to continue talking about variables, formulas, and equations and their use in business. In the first part of this section, we went over the equation of a line, used that equation given values of x to calculate y, solved the equation for x, and then given values of y, calculated x. We're going to go further into linear equations in a future section. But for now, let's turn to other types of formulas. Formulas and equations are employed constantly in finance and accounting, among other fields, to calculate important values like compound interest and internal rate of return. These formulas not only have variables, but also require careful attention to units in order for the answers to come out correctly. So in the example we looked at in example 7.1, there were no units. It was just a mathematical expression. In the formulas we're going to turn to now, there are units, and they make a difference in terms of what comes out in the end. The formula we're going to take a look at in order to flesh out some of these concepts is the formula for compound interest. The purpose here is not to encourage you to take advantage of compound interest, although you should whenever possible, but to take you through the process of using a formula like this a little more concretely than usual. So instead of just saying, here's a formula, use it to do something, we're going to talk about the use of formulas in general by looking at this one in particular. So just a little background, compound interest is what happens when an investment has regular interest payments which, once made, are included back into the investment principal. This means each subsequent interest payment is made on the principal plus the prior interest, thus earning interest on interest, which is why it is known as compounding. Investments are made for a number of time periods, and the interest payments take place at regular intervals during each time period. Here is the formula to calculate what a given investment will be worth at a future time under compound interest. So this formula says A equals P times 1 plus R divided by N, and that quantity, 1 plus R divided by N, is enclosed in parentheses and raised to the exponent N times T. There's a lot to unpack there. Because variables are used here, such a formula would be given along with an explanation of the parts. It would look like this. So here we have that A equals the amount the investment is worth after T time periods. So that's going to be the end result of the investment. P is the initial amount of the investment. So that's however much you invested in the first place. R is the interest rate. N is the number of times interest is applied per time period. T is the elapsed number of time periods. So you have a value A that you're calculating, and you're going to be using P, R, N, and T as inputs. When formulas are given along with explanations like this list of variables serves as a guide to what you need to prepare and plug into the formula. So they're incredibly helpful. There are some things to note in the one that we're looking at. We are calculating A, the amount the investment is going to be worth after T time periods, which is an amount of money. We're going to use P, which is also an amount of money. P is the initial investment. So A and P are both in units of some kind of currency. Often that currency is going to be US dollars, but it could be something else. The quantity 1 plus R over N, all raised to the NT power, is made up of rates and counts, and it doesn't have any units. So the only units to keep track of are the currency units that you enter into the problem accompanying the value of P. What this means is that if you measure P in dollars and do the calculation, then A is going to come out in dollars. If P is measured in thousands of dollars, then A will come out in thousands too. So the units that this expression is going to produce, that this formula is going to produce, are going to be some form of currency. But what that form is up to you when you calculate it. You choose in terms of the currency that P is in when you plug it in. That's what units A will be in when you get it out. Moving on to R, which is the interest rate. The letter R is used to represent the interest rate. This is very typical. Interest rates are measured in percentage terms. They're quoted in percentage terms like 0.1% or 3%. Recall from our percentage section that percentage notation like that, like for example 0.1%, represents 0.1 divided by 100, which is 0.001. Likewise, 3% is notation for 3 divided by 100, which is 0.03. When using this formula, R has to be entered in its decimal form. It has to be 0.001 if the rate is 0.1%. It has to be 0.03 if the rate is 3%. If you plugged in 0.1 or 3, you would get out the wrong answer. Finally, N is the number of times interest is compounded per time period, and T is the number of time periods you plan to keep the investment. Using a formula like this is not difficult. The actual calculation is not difficult. Setting up the numbers correctly is where the effort goes. But if it's done carefully, the result is assured to be trustworthy. So that's what formulas give you, is trustworthy results as long as you set up the numbers correctly before plugging them in. So let's use this formula to work through example 7.2. Looking at example 7.2, it says you have $1,000 to invest and are deciding between two investments which will earn compound interest. Investment number 1 has an interest rate of 2.65%, which is applied twice yearly. Investment number 2 has an interest rate of 2.5% applied quarterly, which means 4 times per year. Part A says, how much will these investments be worth after 1 year? Based on this calculation, which will you choose? When working on problems like these, I like to have the formula that I'm applying visible and present. So I've put it over here to the left. You, of course, have it in your materials. We have 2 investments here, investment number 1 and number 2. They're going to need separate calculations. For each investment, we have to identify P, R, N, and T in order to calculate A. So P is the initial amount of the investment, and for both investments, we're considering the same initial amount, which is P equals $1,000. Since we're putting our principal, this is the initial investment called the principal, in dollars, we're going to get out A, the amount the investment is worth after T time periods, in dollars. Now we have R, the interest rate, to identify. So investment number 1 has an interest rate of 2.65%. We know we can't just plug in 2.65 as R. We have to make sure to treat that as a mathematical percentage. So this is 2.65 divided by 100. That's what percent means, which equals 0.0265. So R for investment number 1 is 0.0265. Investment number 2 has an interest rate of 2.5%. 2.5% would be 2.5 divided by 100, which equals 0.025. So for investment number 2, we're going to plug in an interest rate of 0.025. Notice what I'm doing is just taking the decimal in the percentage and moving it 2 to the left, filling in with zeros. So 2.5%, moving the decimal 1, 2 to the left, fill in that 0 in the empty spot, becomes 0.025. The number of times interest is applied per time period differs between the investments. Investment number 1 has interest applied twice yearly, so N is going to equal 2 times per time period, whereas investment number 2 has interest applied quarterly, that's 4 times per year, so N equals 4. For both investments, we are asked how much is it going to be worth at the end of 1 year. 1 year is the time period in which this interest is compounded. In both of these calculations, the number of time periods we want to make the calculation for is 1, because it's 1 year later we want to know what these investments will be worth. Applying the formula for investment number 1, we have that after 1 year, it's going to equal $1,000 times, open parentheses, 1 plus 0.0265 divided by N, which is 2. And then we have this exponent, N times T. I'm going to use serial parentheses to show this. N is 2 and T is 1. So the multiplication inside the exponent has to take place first. According to order of operations, exponents are like square roots. They act as parentheses if there's any sort of expression inside the exponent. So 2 times 1 is going to be an exponent of 2. So basically we're squaring what is inside the parentheses. You will get $1,026.68. Now for investment number 2, what do we have? We have our investment at 1 year is going to be worth the initial investment P, which is $1,000, times 1 plus the interest rate, which is 0.025, divided by N, which is 4. So all I'm doing is just plugging in the values that we collected into our formula. Raised to the power of N times T. N in this case is 4 and T is still 1. So that exponent is going to resolve to a 4. 4 times 1 is 4. So you're raising what is inside the parentheses to the 4th power. And what you get is $1,025.24. So based on this, you would choose investment number 1 because you would get a higher payout at the end of the year. So we put dollars in when we plugged in P. We got dollars out when we calculated A. We could have calculated this in thousands of dollars and plugged in 1 for P, and we would have gotten 1.02668 for investment 1 and 1.02524 for investment 2. Those would be in thousands as well. Part B asks, how much will the investment you chose be worth if it were held for 5 years? So we chose investment number 1. And if we're holding it for 5 years, the thing that is changing about this investment is that we're holding it for 5 time periods. So T is going to equal 5. Using the same values as part A for P, R, and N, because those have not changed, we calculate this figure to be $1,000 times 1 plus 0.0265 divided by 2. All of that remains the same, but the exponent is going to change because N is still 2, but T is now 5. So that exponent is going to multiply out to 10. So you're raising what is inside the parentheses to the 10th power. And after 5 years, what you'll have in this investment account is $1,140.69. So if we're doing nothing other than finding an investment with these terms and investing $1,000 into it, you will have passively made $140.69. Again, the point of this lesson is not to understand compound interest. It is to understand the use of formulas, because in business, you're not going to be doing a lot of things from the very beginning. You're not going to be proving these formulas or deriving these formulas from the mathematical rules. You're going to be using these formulas, and your decisions are going to be based on numbers coming out of them. So calculating them with due attention to detail is necessary, and I hope this lesson has helped with that.